Hey, this is OXDF, and today we're doing day 18 of the 2016 Advent of Code, Like a Rogue. And this is part of the 2023 revival of code. Let's take a look at the challenge. This has got another one of these complicated stories. Um, Basically, what I'm going to get is a row. I'm gonna get a starting row. So like it could be this row or it could be this row, and each next row has to do with the three above it, like directly above it, above to the right, and above to the left. And so basically, if left and center are traps, which is the up caret, then and the right tile is not, then the next one's a trap. If left and center and right are traps, but the left one is not, it's a trap. So basically, there's four different like outlays about the one above, about the three right above it that make it a trap. Otherwise, it's not a trap. Um, and so then I just need to go through and step through. In this case, uh, starting with your puzzle input, get a total of 40 rows, including the starting row, so 39 additional, and count how many dots show up. So it's pretty straightforward. We'll take a look. I just tried switching over to the Hack the Box VS Code theme, so let me know if this is like not at all readable or more readable. We'll go with the genday script here for day 18, and this will, I have a whole video describing going into this in the intro video for the series, but it pulls my input here as well as gives me some stub data or files to work with. This is longer than what I had, but nothing crazy. Let's go ahead and start. Let's see, we're going to start by, I'm not going to need a parse function, but we will make a like next row function. That is going to take a row and we'll see, get next row from row. Sweet. And so now with that, we can go over here and write a test for said function. We're not going to need any of these file-based things in our test file today. We'll grab this right here, leave part one stuff in place. So we're going to parameterize this because we're going to get a lot of examples. So we'll call this like row, next row. We're going to pass in a bunch of examples of those. And then for each of them, we're going to say row, next row, test next row on example input. We aren't going to need to parse, and we can just call a next row on row going to be equal to next row. Spell that right? Basically, what we're going to do is for each of the things, each of the pairs we pass in here, we're going to call next row on the row and make sure it equals the next row. I actually typed all this out beforehand. We'll see, I don't know if this is better, but when I was reading the problem, so I'm just going to paste these in right here. This is just the three examples, some of the examples that showed up in the text. So now we have a bunch of those. I'm at a point now where I should be able to, let's slip over here and do PyTest. I have a video showing how to set that up. I'll include a link here. If we hit F5 right now, we're going to run PyTest. And my expectation is I'm going to get a bunch of none equals next row. Let's see. I'll skip. Do we need to save this? F5, where are we? It's not even recognizing. Oh, because I have two test part ones. That's an important thing to do. Let's make this test next row. And there we go. Fails, lots of fails. Good. Just what we wanted. 6 fails. All of them are none equals and then a row. Now we can come over here and actually write the function that's going to do it. So the first thing I'm going to do, because each row I need to be able to, it said in the description, I kind of rushed through this, but that there's kind of implied safe tiles off the edges. So what I'm going to do is just say row equals and put a safe tile there, plus dot. So now I have that. And now I'm going to do a for I in range, and we're going to do len row -2. And the reason we're doing -2 is because we're going to grab 3 at a time. So we only need to go up to this, we don't want to go up to the last item. We actually want to stop 2 before the end so that we don't overflow. We can actually probably do this as list comprehension. Let's see. So we'll put this, we can do I for I in range. So that right now, that works. Now we don't want I, we want to get, well, what we really want to do is we're going to say it's going to be a thing. It's going to be a trap if row sub I comma I plus 3. So we grab that row, that little chunk. And I think we actually, why don't we just do it this way? We're going to say, there's only 4 solutions, right? So we're going to do left, center, and not right, right, center, and not left. Our traps. So we'll do for if in like this. We can just like type these out. And then the other ones were, I believe it's, we'll double check, but I believe it's this. So if it's going to be a caret if this thing is one of those four, else dot. And that is all we, if that's all we need. We can dot dot join this to get a string, and then we can return. We can go check these, but I'm just gonna actually just give my test to go, because if I just pass, we just passed. So we've got the test, we've got the next row generation working pretty well. The next thing we need to do is come down here and figure out part one. And they gave us one example. So let's go here, test part one. We don't need this. We don't need this. We don't need this. All we need to do is say part one on. Let's grab the initial row here. So I guess this part one part's going to need to take a row and a number of total rows, right? So we'll grab this. From here. Whoa. Try that again. Delete. So if we put in that, we know we're going to get 38 safe tiles over the course of 10 rows. We should put this as 10, and this is 38. We better come over to our, before we test that, we should come over here and say this is going to take row and num rows. I don't know if we'll go with that. So that'll be fine. And then we're gonna come. Let's just, while we're fixing up, I guess we can fix this up later. I don't think the tests are gonna run that. So we'll run the test now, and we get 1 fail, 6 pass. That's what we want, and we're failing because we have none equals 38. So that just, we haven't implemented yet, right? So now let's go ahead and implement. So we're gonna say count is equal to len. Actually, let's do. I guess we can do for I in range. We don't even use I, so in Python we really should just make this an underscore to show that we're not using it, but not num rows. And we're going to do cn count is equal to 0, and we can do count plus equals len row dot replace. We're just going to take the traps out, and then we'll count how much is left in the string. And then we're going to say row is equal to next row of row. And so then we should just run. Now what I'm doing here is I'm going to run it 40 times. And that way it's effectively counting 40 times. But because I want to count the first row, I guess technically I'm generating an extra row that I don't ever do anything with, but that's fine. We can live with that. So if we run the test now, we are still failing. Oh, because we don't return. Return count. Let's see what we get now. We're passing. We'll switch this from PyTest to current file. Give it a run on our. Oh, we need to actually set this up. So now we really don't need a whole solve function here. Let's just come down here and say solution 1 equals part 1 of puzzle input comma 40. That's how many rows we're supposed to do. And then we'll do part 2 is equal to none for now. We haven't done part 2 yet. Now, if we try to solve, we get 1987. Then we got it. Part 2, not even going to need to pause. How many safe tiles are there in 400,000 rows? So presumably this is going to take a long time, because otherwise we can come down here. There's not even a test. There's no test to write here. We can come down here. We can rename this run. We'll solve part 1 and 2. I'm being a little bit presumptuous here, but because this might fail, but we want to make the whole algorithm better anyway. So we can call this run. And so this one will be run puzzle input. That happens so fast, there's no need to try to like save the first step. We want 400,000. This is where I'm going to not run it in the standard debugger, but we'll do time Python day 18 and see how long it runs. If it runs for more than 5 or 10 seconds, we're probably going to stop and take a look. But no, 4 seconds gives us an answer. I wonder if this was supposed to be hard and they just didn't make it hard, but that seems pretty straightforward. I'm going to take the win. Cool. Thanks for hanging out with me today, and I'll talk to you next time. Bye.